everyone, and welcome to Review Lesson 2. We're going to be talking about operations with fractions. Equivalent fractions are fractions that have different forms but have the same value. For example, 1/2 and 5/10 are equivalent fractions because 5/10 can be reduced. If I divide the numerator by 5 and the denominator by 5, I get 1/2. If I wanted to state 3 fractions equivalent to the fraction 6/8, I would have to give 3 fractions where I do to the same thing to the numerator that I do to the denominator. For example, I can multiply both numerator and denominator by 2, or I can divide both the numerator and denominator by 2, or I can multiply them by, say, 5. Okay, so all of these are equivalent fractions, but 3/4 is the most reduced fraction because I cannot simplify the numerator or denominator. I cannot reduce the numerator or denominator anymore. Equivalent fractions are helpful because they help us to do operations with fractions. Namely, they help us find common denominators. Now, when I say operations with fractions, I mean the following: multiply, divide, add, and subtract. So those are the 4 operations we do with fractions. Now, this is a review. If we want to multiply 2 fractions or divide 2 fractions, remember, we don't need a common denominator. We can just simply multiply by multiplying the numerators together and the denominators together in the case of multiplication. So I get 9/14 in this case, and that's my final answer because I cannot reduce it further. When I'm dividing fractions, if you remember, the rule is that I take the numerator and I multiply by the reciprocal of the denominator. So I can see there are 2 fractions here. The reciprocal of 2/4 is 4/2. Now it looks just like multiplication, where I multiply the numerators. 1 times 4 is 4, and the denominators. 10 times 2 is 20. Now in this case, I can reduce because I can divide both the numerator and denominator by 4. So my final answer there is 1/5. In the case of adding fractions and subtracting fractions, I can only do that when I have a common denominator. So if you recall, finding a common denominator means I need a number that can divide evenly by both denominators in the fractions being added. So in the case of 7 and 12, my LCD, my lowest common denominator, is going to be 14 because 14 divided by 7, 14 divides evenly by 7, and 14 also divides evenly by 2. Now, what I'm going to do first is I know that I have to multiply 7 by 2 to get 14. So I'm going to multiply 3 by 2 to get 6. I'm going to use a dot for multiplication here just because it looks nicer. And in the case of the second fraction, I have to multiply the denominator by 7 to get 14. So I have to multiply the numerator by 7 as well to get 21. Now that both the denominators are the same, I can add the numerators together. So first, I write it over the single common denominator, and then I can add the 2 quantities to get 27/14. I cannot reduce this fraction because the numerator and denominator do not have the same number that divides them both. Okay, in the case of subtracting fractions, I also need a common denominator in LCD. In this case, I could multiply 10 by 4 to get 40, but actually there's a better number I can use. Better because it's smaller, and that number is 20. So both 10 and 4 divide 20 evenly, and it's lower than 40, which is nicer because we want to keep our fractions small. So I have to multiply the denominator by 2 to get 20. So that first 1/10 fraction becomes 2 over 20. We can see those are equivalent fractions. And then for my second one, I would multiply the denominator and the numerator by 5. And now I can write them over the same denominator. And in this case, I'm subtracting. So I get -8 over 20. And I can reduce by dividing both the numerator and denominator by 4. Now, another way to write this is if I pull the negative sign in the front like this, so that it's in the front of the fraction, and we'll talk about that in a moment on the next page. So before we get into a couple of examples, I just want to go over a few common mistakes or common misunderstandings that happen with fractions. So oftentimes, guys are okay with multiplying or dividing, in this case, dividing two fractions. For example, this case, the one on the far right, is actually very simple because it's a fraction divided by a fraction. And we know that the rule says we multiply by the reciprocal of the denominator. And so this question looks fairly straightforward. Now, where sometimes confusion happens is in a case like this one, where I actually have a whole number on the top, okay, and a fraction on the bottom. And really, the way I can see that is really simply because this line here is longer than this line here, okay? So I can see that that longer line is dividing a numerator of 1 with a denominator of 2/3. If I wanted to actually perform this division, the recommended thing to do is to write the whole number as a fraction. And the way I do that is by writing it as a number over 1. So now I have a fraction divided by a fraction, and I can default to the rule I know, which is multiplying by the reciprocal of the denominator. Now, by the same logic, I can see that this line here is longer than this line here. So this has a fraction in the numerator and a whole number in the denominator. So the way I would rewrite this is I would write it as 1 over 2 divided by, and I'm going to write 3 as 3 over 1. Just to make it easier for me to see. All right. So we can see that we have the numbers 1, 2, and 3 arranged in different fractions and whole numbers, and we actually get 3 very different answers for our computations. Okay. One other point before we do a summary of rules for operations with fractions. And that is this topic that is sometimes confusing, which is what to do with negatives, okay? So as I can see, in our first fraction, we have -5 divided by 4. And if I put that into my calculator, I would see that this is -1.25. In the second fraction, I have 5 over -4. I'm just going to get rid of these brackets because they look confusing. So if I put this in my calculator and I said, I typed in 5 divided by -4, I would also get -1.25. I encourage you to try it and go along with the lesson with your calculator. Now, the next one is where some guys get confused. So what I want you to think about here is I want you to think about the fact that the negative is on the outside of the quantity 5 over 4. In fact, it is kind of like -1 times 5 over 4. So what I would do is put 5 over 4 in my calculator, and I would get 1.25, and the negative is on the outside of that multiplying the quantity 1.25. So in fact, this is -1.25. What some guys do by accident is they think that this negative gets distributed to the numerator and the denominator, and that is not true, okay? Because if that were the case, it would look actually like this question, which is different because if I have a negative number divided by another negative number, well, that is overall a positive number. Okay, so you have to really beware of this one where the negative is out in the front, okay? Now, in the case where we're adding and subtracting fractions, I have a recommendation. Anytime you see, for example, if I had a fraction of 1 over negative 2, by convention, so by habit, we never want a negative denominator. So what I would do is I would rewrite this as negative 1 over 2. In the case where you have negative in the front of 1 over 2, and if you find that confusing, what you can do, what I recommend to do, is put the negative in the numerator if that helps you. Okay, so let's keep this in mind as we do a few examples. I'm not going to spend any time on this chart, but if you want a refresher with 4 examples, this chart will help you remind yourself of the rules for operations with fractions, and I can see that this got cut off here. This should be negative 5 over 14 is your final answer there. All right, let's do an example. I can see here that there are 2 terms, but I'm going to simplify each term separately. I'm going to write 3 as a fraction over 1. I'm going to take the negative in front of that fraction and move it into the numerator. I can see that I have a whole number 6 divided by a fraction 8 over 7. So I'm just going to write that as a fraction over 1. And I'm going to move the negative up to the numerator in the second fraction. Next, I'm going to perform the operation, which is multiplication, in that first term. And in the next bracket, I am going to operate, I'm going to do the division operation, which is multiplying by the reciprocal of the denominator. And I'm going to notice that here I have plus a negative number. So overall, this would be the same as subtracting 1/2 in that term. All right, so I cannot reduce or simplify negative 15 over 4, but I will perform the multiplication in the next bracket. And I can see that in this bracket here, in order for me to perform the subtraction, I'm going to need a common denominator. Now, I could use a common denominator of 8, but I can actually see that both the numerator and denominator, 42 and 8, are divisible by 2. So I can write this as 21 over 4, and then I can also write 1/2 as a fraction over 4. So 1/2 is equivalent to 2 over 4. So that has saved me some time. And I can see now that actually I have a common denominator throughout the rest of the question. So 21 subtract 2 over 4, that is going to give me 19 over 4. All right, we're almost done. So I get negative 15 subtract 19 over 4, which is negative 34 over 4, and I can reduce this to negative 17 over 2, and that is my final answer. So one more thing to do before I get you guys to do some examples. I would like us to write an algorithm for simplifying fractions, operations with fractions. Now, what is an algorithm? There are 2 links here that take us to videos. I'm not going to show them here, but you can watch them. I'll link them somewhere else for you to watch. But basically, an algorithm is a list of instructions to perform a task, and it's really important that these instructions are ordered. So there's an order to brushing your teeth. You are going to brush your teeth, then rinse your mouth out, etc. So you already know what algorithms are, but we're going to apply this idea of algorithmic thinking and writing an algorithm for operations with fractions. So what I want us to do is first we're going to write an algorithm. So we're going to write a list of rules for operations with fractions. And then we're going to turn our algorithm into a flow chart. So the first thing we want to do when we're operating with fractions is we want to look at the fractions involved. And we want to look at the fractions and ask ourselves, are there any whole numbers? And are there any negatives that we can simplify, like we just did in that previous example? The second thing is we need to look at the operation involved. Okay, it's going to be multiplication or division or addition and subtraction. And we know that if it's addition or subtraction, we need a common denominator. All right, the next thing we do is we use our rules to perform the operation. So we know the rules for multiplying, we know the rules for dividing and adding and subtracting. At this step, in step 3, we apply those rules. And finally, we reduce our fraction. So I haven't given an example here because algorithms don't use examples. Algorithms are more general recipes and practices that you use regardless of the example that you're given. So now let's write this as a flow chart. So I like flow charts because I like visualizing the steps in this way. So the first thing we're going to do is look at our fraction, or fractions involved. And then we're going to ask ourselves, are there any whole numbers? Are there whole numbers? Okay. And if the answer is yes, what we're going to do is we're going to write all the whole numbers as a fraction with denominator of 1. Okay? And if not, we're just not going to do anything. And then we're going to ask ourselves, are there any negative signs that we need to deal with? Okay, and if the answer is yes, we're going to simplify. Simplify. Okay, and if the answer is no, we don't have to do anything. But regardless, we need to look at the operation. Okay. And then we have to ask ourselves, is it addition and subtraction or subtraction? And if the answer is yes, we need to find a common denominator. If the answer is no, we don't have to do anything. Okay, the next thing we're going to do is perform the operation. And we might need to look at the rules for this. Okay, so this is where you really need to know how to add, subtract, multiply, or divide. Okay, and then the very last thing, which I'm going to squeak in here, is we would reduce our fraction. Okay, so this is two different ways of basically just stating the process that we use, the algorithm or the set of ordered steps to simplify or to complete operations with fractions. If either one of these two works for you, that's great. We are going to be looking at flowcharts and algorithmic thinking throughout the year. So if you don't quite grasp it now, you'll still have some opportunities to grasp it later. Now, what I would love for you to do is pause the video and try these questions yourself, and then come back to the video and make sure that you've done them correctly. So in the next parts of the video, I'm just going to complete these examples, and you can check your answers.